And we will do this a lot of days right after test. We're going to look at those chapter toolboxes before we start a chapter. We're about to start chapter 1. And so the toolbox is what the textbook expects that you know before you get into the chapter. I'm always going to give you some information on that and not just expect that you know it. So that's what today is. It is a little faster, but it is stuff that's review, so you will want to be taking notes. The first thing that we're going to do, and I think you'll find this nice to know from ACT information. This question actually came up a lot on the ACT. The first thing you need to know are the different types of number systems and what those mean. So we're going to walk through the different number systems and what numbers fall into those number systems. I have a graphic organizer up here. You can write it this way if you want to, but you don't have it. So the first thing that we're going to look at is natural numbers. Natural numbers that are called that because they come naturally. My son is 3, and he says 1, 2, 3, right? And that's what he does naturally because it counts things. Those are called the natural numbers. All the way up to million, right? Infinity, right? All of the numbers, the counting numbers from 1 up. The whole numbers, oh, and by the way, those are abbreviated with a capital N, and in a textbook it would be a bolded N. If you just write an N, I'll take it. It would be abbreviated with N. Whole numbers are very similar to natural numbers. They include 1, 2, 3, 4, all of those, and 0. So they just add 0 into the mix. Some textbooks won't even designate the difference between whole numbers and natural numbers, but some will. Integers. Does anyone know what integers are? Ready? All of these plus the negatives. So integers does include 1, 2, 3, 4, it includes 0, but then it also includes -1, -2, -3, -4, and so forth. We are still talking about the counting numbers, though, so positive and negative counting numbers. Is this good information for ACT? I ask you questions about this one, ACT. And the next one is rational numbers, and I want to point out a word in rational numbers. You see that word ratio? What is a ratio? A fraction. So rational numbers are fraction numbers. Do all of these count as fractions? Yes, because I could write 4 as 4 over 1, and 3 over 1, and 0 over 1. Those are all technically fractions, so those are all rational numbers. Integers are rational, so that's why I've got this graphic organizer where it's a big box around them. But then rational numbers also includes numbers like a half or 0.25. Even though 0.25 is not a fraction, could it be? Who's it for? 0.3 repeated. Is that a fraction? What is 0.3 repeated? A third. So that brings up a category. Any repeating decimal can be a fraction. So yes, that is in fact a fraction. So anything that can be written as a fraction is a rational number, which brings up the question, what isn't a rational number, right? What can't be written as a fraction of 2 integers on top of each other? That would be weird things like the square root of 2. Not yet. We'll talk about that one in a second. Square root of 2, pi, e, any square root that doesn't reduce. And you've probably heard this in Algebra 1 or whenever you first learned this, that these were the non-repeating, non-terminating decimals. What does that mean? It just means decimals that can't be made into fractions. So non-repeating or non-terminating. That means they don't have an end and they don't repeat. Weird things like pi e. So that's irrational. And I would not worry about the symbol. It's using set notation a little bit. They use this is the symbol for rational numbers, and then they use this thing that's for a complement of. So they're saying not rational numbers. That'll get you caught up in that notation now. Rational numbers are use a Q, integers use a Z, natural numbers use an N. Those are the ones you look at. I'll show you something. Any questions so far about what the numbers mean? Okay. So the next thing we need to talk about is what's called set notation. This might help a little. Set notation is a way to describe lots of numbers without listing them out individually. Yes, just grab one. There's a seat right there. Go for it. So anytime there's a lot of numbers to be listed, set notation is useful. So it says list the elements in this set. And we need to learn how to read what in the world this says. This says X such that. So we could read X square or X such that. X, and this little symbol means an element of or part of this set. What does this mean? What is this Z? Integer. So all of this says X is an integer. In English, this says X is an integer. And very mapping notation that says X is an integer, comma, so that means another condition. X is between -2 and 4, including -2 and 4. So what are the numbers that this is talking about? List all the numbers in this set. -2. So this is a fancy way of saying that. Now I know at first glance you say, well, why didn't you just list the numbers? When could this be useful? -300 to 300. I wouldn't want to say that, right? Because that's where this notation could be useful. Of course, on this problem, it seems a little boring, but that's what set notation looks like. I could have picked a different set of numbers here. Would it be beneficial to use this notation if I meant all the rational numbers? Would it be very difficult to write every rational number between -2 and 4? A fourth, a half, an eighth. Oh, we could go on all day. 16, 30 seconds. I would never want to list every rational number between 2 and 4. So that's where this notation is very helpful. Just a vocabulary word. A subset is part of another set. So a set A is called a subset of set B if each element of A is an element of B. So what I mean by that is that if I picked the numbers 1, 2, and 3, those would be a subset of this set. You see what I mean by that? 1, 2, and 3 are a subset of this. If I'm talking about this class, but then I say only the girls, that's a subset of the class. It's a part of the class, but it's not the whole class. It could be the whole class. A subset could include the whole class, but a subset is part of another set. That nothing in common are called disjoint. So two sets that have nothing in common are called disjoint. Some words that you might need to know. Okay, so this here, right here. That means if the actual words for it are an element of, but what you'll think about it is x is an integer. The technical math notation of it is that x is an element of the integers, but just x is an integer. Yes. Natural numbers are just the counting numbers. They just don't technically include zero. No one would ever call you out on that if you forgot that part. ACT doesn't test whether you know that or not. And some textbooks don't even make the distinction between whole numbers and natural numbers. They just use one or the other. And a set that contains no elements is called the empty set. And have y'all seen that symbol before? A lot of times it's used for undefined. Y'all will say that for undefined. What you're really meaning is there is no answer. This set is empty. It doesn't technically mean undefined, but it works for usually what you're using it for, which means there's not an answer. There's nothing in the set. The next one that we'll talk about is interval notation. Have y'all seen both of these on ACTs and in other classes and things? Both. They may not have been described to you in a long time, but you've probably seen them somewhere. Interval notation is using a number line to describe the numbers. When we are talking about interval notation, generally we're talking about all real numbers, so rational, everything in the list, right? All the numbers that are there. Everything except I, which we will talk about later, which is not a real number, and it won't be on number lines. Other than that, generally when we're using interval notation, we mean everything in between a certain set of numbers. Anytime you are using interval notation, if it's new to you, I would highly recommend drawing a number line. Because what you really are doing is using a number line to describe where x is. So if I have this representation on a number line, the bracket means all the numbers including 2 that are greater than 2. Everyone see that? So this is every number greater than 2, including 2. How do you write that in interval notation? Is you go from 2 to infinity. 2 is the lowest number. It goes on forever, so anytime you want to say it goes on forever, your biggest number is infinity. Does anyone remember from Algebra 2 when you use a bracket versus a parenthesis? When it's included, use a bracket. When it's not included, use a parenthesis. Because of that, infinity never gets a bracket, because mathematicians would say you can't equal infinity. You can't get there. It's not really a number. So they always put a parenthesis on infinity, so you don't really have to think of infinity. It's always a parenthesis. So if I look at this next, there is going to be 2 of them. Why does there have to be 2? It's broken up, right? It has some numbers on the left and some numbers on the right, and I can explain that by just saying from here to here. By the way, this is a small note, but always start from the lower number to the higher number. It's incorrect if you don't, but it also just kind of sounds silly. Like if you were guessing my age, you might say, well, Miss King, you're probably somewhere between 25 and 30, or 25 and 35. You wouldn't say you're probably somewhere between 35 and 25. Even though you mean the same thing, it just doesn't sound right. Does that make sense? left-hand piece. Negative infinity goes on forever, so we're going to say negative infinity. And then it goes all the way up to negative 3. And because it has a parenthesis there, it will be a parenthesis. It means it's not including the negative 3. Some textbooks and ACT will occasionally use an open circle for the parentheses. Have y'all seen that before? So if you see an open circle, that means the same thing as a parenthesis. If it looks like that, and then closed in circle that way. Those would mean the same thing as the bracket parentheses. So those are the same thing. Textbooks will do different things. ACT uses both, so you need to be aware of both. And then this piece is from negative 1 all the way. If you see this written in a textbook or in the ACT, they will put that little symbol in between them two, and it's a union of two sets, saying this one and this one together make up the answer. If you leave that off, I won't count off, but just know on the ACT you see it.
Mine, I didn't see that. Mine was that
it was that parenthesis here. And so in this notation, I'll just copy that down. If it were an open circle, it would be a parenthesis also. And what that notation means is every number all the way up to negative 3, but not including negative 3. Any questions? Polynomials. A polynomial is a function that's written with a constant times x to a power, another constant times x to another power. This notation looks a little scary, but an example would be 3x to the 5th plus 7x to the 4th, 3x cubed plus 2x squared plus x squared. Something like that. But they use ends because it could be any power or a polynomial, when simplified, cannot have negative exponents. So there's no negative exponents, they're all positive exponents. The powers are not fractions, they're whole numbers. And there are no variables in the denominator. And there are no variables in a radical. So it's like a quadratic or a cubic that you learned in Algebra 2. So that's a polynomial. And a couple of things that they will expect you to know in this book are these words here. So we're going to write down what those words mean. Degree, coefficient, variable, constant, and exponent. Does anyone remember what the degree of a polynomial is? The highest exponent. Good. The largest exponent. So, in my example up there, 5 is the degree. The highest exponent. Be careful. You expect them to be written in descending order. Be careful. It is the highest power. It may or may not be written first. Does everyone know what I mean by that? They may try to trick you and put the highest power later, but it's the highest power. A coefficient. Does anyone know what a coefficient is? Good. A number besides variables. Number in front of variables. I have a lot of choices here. All of those are coefficients. The 3 is a coefficient, the 7, the negative 3, the 2, the 1. Those are all coefficients. A variable is a letter that stands for a number. it does mean that number can change. So if a variable is an x, that means that if we were to look at that graphically, the x can change along the graph. So it is a changing quantity. Usually x or something like that. A constant is a number that stays the same. It's just a number with no variable. In this problem, what is the constant? So the example I have up there, what is the constant? -1 is the constant. It doesn't have a variable inside it. It's a number that's not going to change, and so that's a constant. Does anyone remember what the leading coefficient is? The one in front. Now, if our polynomial is in what's called standard form in descending order, that won't mess us up. But I'm not going to say it that way because HCT will try to trick you on that. The leading coefficient is the coefficient beside the x with the highest power. Now again, if you order it correctly, it will be in front. That's where it's the name leading coefficient. But it's the number beside x with the highest power. So in this case, it was 3. Any questions so far? Oh, you're fine. Okay, that is the last thing that I'm going to teach, but I want the rest of class to still be time for me to teach, but just through you asking homework questions. You have 1 through 37 to work on, ask me questions. If you know there's